Charges do not have a direction. Okay? Tell me something else that does not have a direction.
Speed. Speed.
Speed. Also mass, right? So I have a mass of 90 kgs. Okay? I have a mass of 90 kgs. What is the direction of my mass? It's a meaningless thing, right? Okay. How much money do you have? Do you have 100 Qatari riyal? Let's say you have 100 Qatari riyal. In which direction do you have a Qatari riyal? It's a meaningless thing. Okay? So the money, dengue, that's what we call in Kyrgyzstan, where I was previously. So the money, it has no direction. The force has a direction. Okay? So there are different types of physical quantities. There is a physical quantity that has no direction. And there is a physical quantity that has a direction. Force is a physical quantity with a direction, and mass is a physical quantity without direction. Now I'm talking about charges, right? Now what kind of physical property the charge is? It's a kind of physical quantity that does not have direction. We call it scalar, right? Scalar. Okay. So charge do not have direction. Okay? Charge do not have direction. That is why it's a scalar quantity, right? It's a scalar quantity. The second one. What is the other property of charge?
It always has a mass.
Yes. Is it like, for example, if you are going to give charge to something, how is that possible? You are going to give it electrons. You are going to take protons from it, right? Something like that. So when you are going to give something an electron or a proton, you're also giving it some kind of mass. Is it possible that you are going to give charge to a body without any mass? That's not a possibility. So if there's a charge, there would be mass. So the charge is always associated with mass. Charge is always associated with mass. Right? That's the second property. Can you tell me about the third one?
It's relativistically constant.
Yeah, that's the fourth one. You're right. We can call it the third one, that's not a problem. But there is another property of the charge that is known as the property of quantization. That's called as the property of quantization. Okay? The quantization of charge. Okay? Quantization of charge. Quantization of charge. Right? The quantization of charge. What does it mean? So let's talk about buying some eggs. Right? Have you ever bought some eggs? What if you go to a shopkeeper and ask him for half an egg? Is he going to give you half an egg? He's not going to give you half an egg. He may give you a few choicest expletives and he would say, get out of here. Right? Because I can't really sell you half an egg. How am I going to tell you half an egg? What is an egg made up of? Egg has a shell, egg has an egg white, egg has an egg yolk. Can he separate these out and give you half of it? No. So whenever you're talking about egg, you can have 1 egg, 2 egg, 3 egg, and that's it. You cannot have 3.5 eggs. Huh?
You can kind of separate it.
But you cannot sell it, okay? Egg comes along with it. So what if you go to the market and try to buy a marker, and he gives you a marker like this? Are you going to buy it? No. You're going to ask, where's the cap? I'm not going to buy a marker without a cap, right? So a marker always comes with the cap. Similarly, when we are talking about charges, it always goes from one body to another in the form of electrons. So whatever the charge of electron is, it's going to be a multiple of that. Okay? Now let's think that the charge of electron is -3. Okay? The charge of electron is -3. Okay? If I give you 2 electrons, how much charge am I giving you? -6. If I am giving you 4 electrons, how much am I giving you? -12. Right? Is it possible that I can give you 13 charges? No. Why? Because they can be 12 or they can be 15. Okay? Because as the charges are transferred, it's always transferred in terms of electrons. Okay? So charges are always integral multiple of the charge of the electron. Okay? So charge of a body is always an integral multiple of the charge on an electron. You understand? Okay? So charge on any body, charge, the total charge, right? The total charge on a body is integral multiple of the charge on an electron. Okay? And what do? We call the charge on an electron with the symbol E. Okay? Charge on one electron. And we represent it with the letter E. Okay? And how much is it? It's equal to -1.6 multiplied by 10 to the power minus 19 coulombs. Right? Coulombs. Right? That is the charge on one electron. It's a very very small charge. Okay? Charge on one electron is very small, and this is the amount of charge that we have on one electron. Okay? Now, if a body has 3 electrons, it's going to have 3 into 1.6 into 10 to the power minus 19 coulombs. Right? The charge will be multiplied by 3 if we are giving 3 electrons. If we are giving 7 electrons, then we multiply this value to 7. Okay? If we have 1,000 electrons that are being transferred, then we are going to multiply this value to 1,000. Okay? So if we represent the total charge with the symbol Q. Okay? And the charge on an electron as small e. Right? So let's write Q. Let's write the capital Q, right? Capital Q is total charge on the body, right? E is charge on one electron. Okay? N is any integer, right? Integer. So what's the formula going to be? The formula is going to be Q, the total charge, is going to be any integer multiplied by the charge on one electron. And this whole thing is known as a quantization of charge. And E would be known as one quanta of electric charge. Okay? So if somebody asks you what is 1 quanta of an electric charge, you would say the charge on electron would be 1 quanta of electric charge. And what's the value of 1 quanta of electric charge? That would be a negative 1.6 into 10 to the power minus 19 coulomb. Right? Go ahead, take a note of all of these.